Let's start with an example, a mechanical system consisting of a mass attached to a spring. If the spring is stretched or compressed, the spring will produce a restorative force to return to its original position. However, if we assume the ideal case that the system has no friction, then what actually happens is that the spring will overshoot its starting position, pull itself back, and overshoot again. In other words, the mass and spring will oscillate, bouncing up and down continuously. It turns out that the rate at which this oscillation occurs, or its frequency of oscillation, is entirely determined by the properties of the system, not how the system is set in motion. This system has a natural frequency of oscillation, omega naught, which is equal to the square root of k divided by m, where k is the spring constant or the stiffness of the spring, and m is the mass of the attached body. If m is made larger, the natural frequency reduces, meaning it takes longer to oscillate back and forth. If the spring is made stiffer, meaning k becomes larger, then the oscillation becomes faster. Notice that k and m are both properties of the system. They are not affected by how we pull or push the mass to start it in motion. This means that omega naught, its natural frequency of oscillation, is how the system wants to vibrate on its own.